lane. So we talked about before that if I want to find the expected value of two variables, then we can just sort of add the variables, right? Remember how we said if I know the height of the boys on the basketball team was something and the girls is something else, right? We said you could add the expected values to get the total, or, right, imagine, I think we had a problem that said John went to India and like the conversion rate was blah, 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 and he wanted to like see if he could buy the bicycle, and it was 43S minus R or something like that. And we said find the expected value of that. And we had the formula that said expected value is equal to 43 times the expected value of S minus the expected value of R. And most people got that one really well. They were like, oh, okay, I just need to multiply and then either add or subtract depending on what I want. Where we struggled a bit is when we said find the standard deviation. So, the standard deviation of x plus y equals the square root of the standard deviation of x squared plus standard deviation of y squared. And again, most people have this. Where we ran into some problems was on one of these two. When we had this, standard deviation of x minus y. That is the exact same formula as above. And the reason is because when you have a standard deviation, you're always adding the distance. Regardless of whether it's above the average or below the average, you always want to add it to see the total distance away. And then we had problems like this. If y'all remember the formula, we had standard deviation of, let's call it a number, call it 25 times x minus 3y. Right, where you had a number times x minus a number times y. And this is equal to, well, 25 squared times the standard deviation of x squared plus 3 squared times the standard deviation of y squared. This is times here. So, take the 25, square it, times the standard deviation of x squared, plus take the 3, square it, times the standard deviation of y, and square that, and then on your calculator get the whole square root of that. So that'll be the standard deviation of the combination. Victoria?
If it was like 43 is minus R, do you just assume the 1 is?
Yeah. You mean assume this is a 1 here?
Alright.
Yeah, does that make sense? Mm-hmm. It's a good try.
Where are you getting these numbers from?
This is purely off the top of my head.
Oh, okay.
Yeah, purely off the top of my head. These formulas are going to be crucial to what I'm about to do. That's why I'm just sort of like reviewing them. Okay. All right, so let me move into the problem now about the wrestlers. And, sorry. So Alex, right, yeah, you see, sorry. I think both of them have wrestlers, but I'm on the one that says model problem. I'm on the one that says model problem. So Alex, if I'm here, is this going to pick it up? No. So we need to move it there?
Yeah.
Telemark. All right, so the problem says, no, I'm going to be here, Telemark. I'm going to be here. So make sure you get this board, please. Okay, a wrestling team can elect 3 wrestlers for a match. The team score will be a combination of the 3 wrestlers' individual score. Each wrestler's score is normally distributed, and all the scores are independent. For many of the past matches, the following table displays the mean and standard deviation for each wrestler's scores. So wrestler 1, the mean is 25, standard deviation is 3, and so on. Wrestler 1 thinks he can beat his personal score of 30. What's the probability he does this? Well, let's take a look. This first question is just good old normal CDF. Many of us can do this on our own. Let's try it on our own. Should look something like this. And again, if you need some support, I'll be drawing it up here. So we start here. Right? We always have a picture. Remember, always have the picture. This makes the logic work nicely. Okay, I'm going to do this, do this. Then what are they asking me? Well, they're saying this is wrestler 1 score. And this is 25. And they want to know what is the probability he can beat his best score. So here's what I'm going to put into my calculator. Please verify that this is what you would put in. This is what I'm going to put in. And what I got when I did this, and again, please verify that you're getting this. And again, of course, I could have, and perhaps likely did make an error, but this is what I got. Bless you. So this is the kind of thing we're talking about for tomorrow. This is the kind of thing we're talking about for tomorrow. Okay. Okay, so any questions on A? What is this? Any questions on part A? Okay. Let me look at B. Let me look at B. So on B it says the second place team scored a combined score of 75. What's the probability that this team, in other words, the team we're on, wins? Well, we need to find our combined score. Let's find our combined score. Our combined score will be what? It will be 25 plus 21 plus 24. We want to find the expected value of wrestler 1 plus wrestler 2 plus wrestler 3. That is our combined score. Whatever 1 gets us, plus 2 plus 3. Shamar? So this will equal, well, wrestler 1 is 25, 21. So this is going to give us 70 is the expected value of our team score. Now we need to find what is the expected standard deviation. What is the standard deviation of the team score? So we need the standard deviation of wrestler 1 plus wrestler 2 plus wrestler 3.
Same thing we just had about?
No. So here's the thing. This is why I went over this formula. This is a standard deviation. So we want to do this. It's the square root of wrestler 1 squared. So wrestler 1 is 3. So 3 squared plus y, which is 4 squared, plus, in this case, there happens to be a third one. So let's just add that on. The third one would be 5 squared, which is equal to the square root of 50, which is, a number that you'll get on your calculator. Let me stop here before I draw the picture. And again, those who got this, keep on going on your own. But I want to see if there are questions on how we got this.
I'll ask questions.
Okay. So now, let's go to the next step, and let's see what is the probability that our team beats the other team. So, let's draw our picture. So, again, we'll draw our up and down. We're still on 1B. Model problem B. So, here's the mean. The mean of our team's score is what? 70. And we want to know what is the probability we get higher. Precisely. Here's 75. And this is what we need to find. Right here. We need to find this area right here. Everybody knows how to do this. Here's what I'm going to plug into my calculator. But before I plug in, I want to see if there's questions on the picture. Let's stop here.
How did you know to put 75?
How did I know to put 75? Can somebody answer this question? How did we know? Kendra, how did you know to put 75? She got it. Okay. More questions on the picture before we do the number? Okay, let's finish it up. So this should go into our calculator as this. Here's what goes into our calculator.
That is 0 infinite.
That's infinity.
You put infinity over there?
Right, because in theory, right, the like highest, this goes on kind of. And what I got was this. Please verify. All right. Questions?
But how did you put that in there in the first place?
Where? In the calculator?
Yeah.
I'll show you how to do that.
Yeah, I got it. Okay.
Any questions on this? Hey, Paul. Oh yeah, you can leave it as the radical if you want, or you can write the decimal with 3 decimal places. Your choice. 7.0711. That's a cool number. 7.0711 is 711. Okay. What's up, Karina? Okay, so let's address individually. Let me do another one. So guys, I want to move forward. I want to move on to the problem number 3. I want to model a little bit of that, not everything. I want to model maybe 1 or 2 parts. So I'm going to model 3A right now. 3A about the twins. You need to do B through the rest, but I'm going to model E right now. Sorry, A. I'm going to model A. Vex, or Thelma, can you give that back to Alex, please? Both, yeah.
Yeah.
Garcia?
Yeah.
Okay. 3A. All right. All right, folks, here we go. So 3A. We ready for 3A? Mm-hmm. Because 1 is a lot easier. Better I do the harder one, right, Shamar? Okay. All right, so 2 twins are having a birthday party. One of the twins plays basketball and invites only her teammates. She approximates that the amount of people is normally distributed with a mean of 12. So for basketball, we have a mean of 12 and a standard deviation of 2. The other twin plays soccer and invites only her teammates. Soccer. Normally distributed. Alright. I'm not going to do A and B because they're actually too incredibly easy. Okay, let me do C. That's where the money's going to be made. Let me do C. A and B, everybody can do. Normal CDF, boom, boom, boom. Let me do C. C says, find the expected total number of friends that will attend the party and the standard deviation. So here we go. We want to go expected of basketball plus soccer equals what? Well, that's going to be 12 plus 17, so 29. So 29 are the number of people I expect. 12 from the basketball team, 17 from the soccer team. All right. 3C. 3C, Dex. And the last thing we want now is the standard deviation of basketball plus soccer, which is, well, square root of the standard deviation of basketball squared plus the standard deviation of soccer squared. Standard deviation of basketball is 2 plus 4 squared. So this will be the square root of 20. So just another model of how to do that. And this is equal to, if you wanted to get the decimal, 4.472136. So you need to at least do up to here.
3 digits.
You got an email.
I did, okay.
You got something.
Something.
It's popped up.
All right.
That's a 14-minute video, sir.
So
questions?
Oh yeah.
That's fine. It's fine. We have enough space now.
Wouldn't that be the answer?
So-
29 and 4.4.
So this is the expected value. This is the standard deviation.
So both of them.
Both of them. All right. So we have till 1:05. You have plenty of work to do. I'm gonna pick up the homework that was due today and pass back all this.